Hello again and welcome to our Engineering Skills Starter session. If you watched my previous videos, you'll know how hard I've been working on my making skills. After all, I can't expect to make a successful prototype or model if everything all falls apart, can I? I can cut, score, fold and join, and look, this is the result. It's amazing. Do you remember how I made it? So I had to measure carefully and accurately and precisely and cut and score and fold. Why not have another go yourself? So I've got my shape. Perfect. The only thing is the shape is great, but it's still not going to do what I want it to do. Whatever you are making, it's got to have structural integrity. Listen to me talking like an engineer. What that means is it's got to be able to do the job it was made for. If it's a wall, then it needs to stand up. If it's a tin of biscuits, it needs to open and close. As an aside, but only for me. That's why engineers choose their materials carefully, to make sure the materials are up to the job. Some need to be rigid, some need to be flexible, but they all need to work for whatever structure you're making. So what do I need to do to this cuboid then? Well, to start off with, it's not very strong. If I put any weight on it, it will break, and that will break my heart with all of the effort I've put into creating it. So I need to make it stronger. So how can I do that, I hear you cry? First, we're going to think about the material I've used and how I could adapt it to make it do what I need it to do. I need to make sure it has structural integrity. There I go again with my engineering speak. Why don't you try it? Say structural integrity or structural integrity. So I can do a few things here. I can stiffen the material and I can strengthen the structure. What do I mean by this? Well, stiffening the material means that when I apply a force, it is more likely to go back to its original shape. Watch. With the paper here, when I apply a force, it doesn't go back to its original shape. But with the card, when I apply the force, it goes back to its original shape. So why has that happened? Well, the card is stiffer than the paper. So if I needed stiffer walls, I'd choose card as my material. But then if the card is not stiff enough, or I've only got paper, then there is a little something that can be done to add stiffness to your material. These have been engineered to be stiffer. Would you like to see how? The first one has been laminated. Laminate means layer upon layer upon layer has been fastened together. Take a look. You can see if you look closely here that this is actually made up of multiple laminations that I've glued together. And when that glue dries, this piece of card will then become much stiffer than a single piece of card on its own. So that's laminating. I wonder if your teacher has ever used a laminating machine before. You might have seen one in the classroom. You might even be able to see one now. A laminating machine can be used to laminate materials, but this time rather than using glue to fuse those layers together, we use heat and a laminating pouch. I could take this piece of paper and I could place it in this pouch, and now we've already laminated it. What we're going to do now is join it by using the heat from the laminating machine. Let's look at the next one now, corrugation. Have you heard that word before? Have you heard of corrugated cardboard? What is different here to the laminating? After all, there are still layers. What do you notice if I hold it up? There, what do you notice here? Maybe you have a piece of corrugated cardboard you could examine. If you join in with me, if not, watch carefully. What I'm going to do is I'm going to pull the top layer of the cardboard off. So it's slightly different from the lamination because the layers are not all flat. One is wobbly. So why? What does that do? Well, the corrugations allow the card to move flexibly, but it's stiff and rigid enough to carry weight. Clever, huh? Corrugated cardboard is also really difficult to rip, which is why it's used in packaging for so many things. Maybe if you get the chance, you could do a bit more research into the history of this fascinating material. The last sort of stiffening I want to show you is called ribbing. And why do we think it's called ribbing? That's right, it's like a rib cage. And what does a rib cage do? It protects your insides. That's why that's exactly what the ribbing does here. It's like a shock absorber. The pockets of air created inside the ribs stop a force from squashing the material completely. It bounces back. Have you ever seen bubble wrap? Well, that's the same idea. Just got to pop a couple. There we go. So we've looked at 3 different ways of stiffening the materials. Time for you to have a little go. You'll need paper or card, glue and some art straws. See if you can make pieces of laminated, corrugated and ribbed materials. Have fun. Welcome back. Did you enjoy experimenting with the laminating, corrugating and ribbing? Did you find it fiddly at all? I know I did the first few times I tried it. So those are some different ways you could use to give your prototype more structural integrity. Remember what that means? That's right, it does the job it's supposed to. So as an engineer, what you'll need to decide is whether laminating, corrugating or ribbing is the right approach for you. Or maybe none of these. I've tried all 3, and any one of these methods could be used to make my cuboid stronger. But I also want to show you something else, something to really think about, something that will make our structures even stronger still. Bridges need to be strong, right? They need to hold heavy weights, people, cars, lorries, even trains, or even aircraft. Well, there is a shape that plays a really big part in making sure that bridges have structural integrity. Can you think of what shape that might be? Have a think a second. That's right, triangles, the king of strong shapes, ladies and gentlemen, a triangle. Here's another example of the superhero that is the triangle. Look at the bike frame. What shape can you see? That's right, you can see triangles. What do you suppose would happen if the bike frame had square or rectangle shapes? A triangle is much stronger than a square. When you push hard on a square-based structure, it collapses. But a triangle does not collapse as easily. It fights back. So using triangles should make a structure much stronger. When we strengthen a structure using triangles, we call it triangulation. Take a look at this. So if I add triangles to my frame, I will make it stronger. In fact, I know how to stiffen and strengthen now. Over to you. Let's see what you can do. Explore the methods. The more you test things out, the easier it will be to choose which method you want to use in your engineering design project. Good luck. Have fun. I'll see you soon.